Laura, TDI Challenge, just tell us about what this event is.
Yeah, it's Technology Design and Innovation Challenge. It's been running since 2003 and it's for design and technology students aged 14 to 19 years old.
So it's hosted by the MTA, correct?
That's right.
And how many students are involved and what are the ages?
So we have entries in the low hundreds that we've received this year, and that's from students 14 to 16 is one category and 17 to 19 is the other. And then they go through an initial judging process by a judging panel that's made up of our Education Development Committee. Then the ones that are selected through to the finals, which is 6 individuals in the 14 to 16, 6 in the 17 to 19, and we've got 2 group categories aged 17 to 19 this year. So 20 in total that have made it through to the finals.
Beth, tell us about your product here, your innovation.
Okay, so it's a portable Apple light that you can walk around with and use it, and then when the battery inside has died, you can put it back on the base and it will charge back up.
Okay, do you want to just pick it up for us here? So have you've done everything here, from the design to the manufacture, every part's from the bowl to the electrics?
I've done every single bit. I've designed the shape, I've used the software to create the shape, laser cut it, sanded bits down, I've used a wood lathe to make the bowl, I've soldered every individual wire inside, all on my own.
Let's look at the consumer element. Why did you develop this? What, would it sell and what would people like about it?
Well, I think what most people like about it is the portability of it. Like, you can walk around, use it for 5 hours, and then you can put it back when it's done. But I think it's also the shape, and I think it's quite a fun shape, and like the colours, and especially for kids, because they like the colours and stuff.
So the idea is you put the Apple back onto the bowl, and when it's on there, it's charging, and then once it's charged, you can literally take your light anywhere in the house or the property.
Yeah, you can put it on the base, it'll charge, because there's a Nokia battery inside, charge that up, and then you turn the little switch off so it doesn't run out. Walk away with it, use it however you want, and then when it's dead, when all the lights are gone, you put it back on, and it takes a couple hours to charge back up.
From start to finish, from the original brainwave to the complete finished article that we have here, how long did it take you?
Well, I started this in October and I finished it yesterday, so it's taken me quite a long time just to get it perfect, because I've got so many different shapes and sizes and all different things, and it's broken so many times because acrylic is quite a brittle material, so I've had to put different things in the slots to make it a little bit more flexible so it won't break anymore. It's taken quite a while. You're
talking about problems you've encountered along the way, which is important, because you learn from potential mistakes and problems as you go. What other things have you come across that haven't worked?
Well, we did have a problem with the coils to begin with, because my original Apple size was quite big and there was just over an inch gap between the 2 coils, and the magnetic charge just wouldn't reach. So I've had to change the size and make the coils just a tiny bit closer, and now they properly do charge. So that was a big problem I was having, but sorted now.
Are you going to win this?
I hope so. I don't mind though, because I'm just happy to be here, to be honest.
Okay, and what is their challenge? What are they doing?
They submit their design and technology coursework. So there's many student competitions out there that require a lot of extra time for innovating new projects, and we think it's good to recognise the hard work that students and teachers put into their normal coursework projects. So they just submit the coursework projects that they're doing as part of their GCSEs or BTEC.
What have we got here, Miles?
Okay, we've got here a Bluetooth helmet indicator. It works off between Bluetooth between the helmet and the handlebars. So we hold down the button and the indicator should light. Then we turn it off. Then the other one, we hold down the other button and it should light. You can hold them both down together.
That's like hazards, is it?
Hazards, yeah. So if you need a hazard on.
So if you've got a puncture or you break down.
Or if somebody's stopping in front of you, just click the hazards on.
And how long did it take you to develop this, and what gave you the idea? Are you a keen cyclist?
I'm a bit of a part-time cyclist. I do enjoy it, but when I have the time. It was just when you come to traffic lights or crossing, the arm outstretched, it's quite hard to see at night. So the visible illumination is quite useful. It's much easier to see than sticking your arm out, and safe because you don't have to take your hands off the handlebars.
And give us an example of what maybe one of them has created or crafted.
So we've got some really wide variety this year. We've got one young lady who's done a chick incubator, a very stylish chick incubator. We've got another chap who's made a rowing seat that's suitable for a disabled person. We've got someone else who's developed a Bluetooth biking helmet that indicates when you want to go left or right. So it's a really wide range, really good ideas, and I always find it so inspiring what they come up with now. It's fantastic.
Jacob, tell us about this here. What are you doing? What have you got?
So, as a product, it's a unique and contemporary shoe storage system. It uses compression mechanisms made of different types of wood, as you can see, in the way that it uses a tension spring, so whereby you squeeze the top of the mechanism.
It's a bit like a peg, like you got here.
Peg, yeah, that's my inspiration. All came from standard close peg. You adapt that, make it different, use different springs, different materials, make it out of wood, more attractive.
Give us a quick example. So what are we doing here?
Example, squeeze the top, shoe slips off. Want it back on?
And why did you choose this? Where did the idea come from?
Well, it all came from a problem. I'm not sure if you can see, but up here we've got how we store shoes in my house. It's a box and a basket. Simple, functional, but the shoes can get damaged, dirty, collect dust, and yeah.
And does it matter how big your shoe is, how big your foot is, or how small it is?
No, we've tried it from a female size 3 to a male size 10, so the versatility of this is very...
And then we're assuming then you just add this to a wall, yeah?
Yeah, this is straight onto a wall, and there you go.
Are you a shoe-in for a victory?
I sure hope so we'll see. Thank you.
I'm looking forward to going inside, because inside you've got, is it the 20 finalists and are kind of exhibiting their product or whatever they've created, correct?
That's right, they're all in there today. They're currently being judged by our judging panels, so it's a bit of a hub of activity there. We also encourage their parents and teachers to come along just so that they can support them and find out more about the industry and what's going on.
Is it about the idea, or do their products actually have to work?
They have to bring a working product with them, so it can't just be the theory of things. So there's again, it doesn't have to be market ready, but it's good just to have something there that they can show the judges, whether that's prototyping or a finished product. But usually their coursework, they have to have a finished product for that, so that's what we tend to see here in the finals.
Will, what's the Voom box?
The Voom box was my design. Well, the school gave us a design brief. It literally was a non-powered application unit, and this is what I came up with. It's completely unique to me. I've completely designed it from scratch, as you can see on the board, with different designs completely all the way through, and this is the Voom box.
So it's an amplification device. How does it work? How does it amplify?
It works on the fact that metal reflects the vibration of the sound, and this, as the sound is produced from the phone, it reflects all the way up through the tubes into the actual speakers and projects the sound to make it louder, which generally works.
We've talked about the judging panel. This is a great collaboration here because we've got some really big names. Obviously, the event's being hosted here at Mazak, but we've got companies such as XYZ Machine Tools, Mazak, as we've mentioned, DMG Mori, Samvik Coromant, Renishaw, Autodesk. Some pretty big names on that panel.
Yep, that's right. And again, I think that's one of the fantastic things about this competition is that the students have a chance, 20 minutes with each judging panel. They're being asked questions, they're being mentored, they're being given advice by the judging panel on how they might be able to improve their product. So I think it's a really good opportunity for them, and you don't often get that.
Simon, this is a little bit different. Tell us what you've designed and made.
So I've made a scale electric lap counter and timer. So essentially I looked at the market, thought stuff's expensive and it doesn't do everything that I think a customer would want it to do. So can I make my own? So I designed a few circuits, designed a case, got that laser cut, manufactured it, glued it, sanded it by hand, and I developed a lap counter.
Okay, and it's a lap counter. Is it a lap timer as well?
Yeah, it times laps as well. So some of the products I looked at don't time as well, or they do one or the other, but mine does both, and it's got RGB LEDs to provide like a start sequence or visual display.
And how accurate is it?
So it will time to the nearest hundredth of a second, but because of the Arduino microcontroller I'm using, that has a clock speed of 16 megahertz. So in theory, we could be going to thousandths, millionths of a second, perhaps with less accuracy, but the functionality's there.
Let's see it in action.
Okay, so
So what's the Harrow Josephson engineering team developed here?
So we've developed a device to help blind people navigate by using ultrasonic waves to kind of like sense where different objects are in their surroundings.
So what would you do then? You'd wear these glasses and this headset?
So yeah, you'd wear this goggle in front, and you'd wear the bone conduction headphones at the back. And this circuit box here would be in a backpack, just something like this. And you would essentially turn the device on, and it would automatically just give you information about where things are.
How's it doing that? Where the message is coming from, and how are they generated?
Oh well, okay. So firstly, you have the ultrasonic transducers send out beeps. Send out kind of waves of ultrasonic sound, and it kind of receives that as well. And using kind of how bats use echolocation, they are able to like measure out distances, and that transfers information to the Arduino boards, which then also transfer information to the bone connection headphones, which sends them out with like beeps with different frequency, and even when it gets to a certain distance, like a meter, it tells the person to stop.
So, Ravi, have you tested this?
Yeah, so we've done this with a number of other pupils in our school, and we've had them blindfolded because we weren't able to test it with blind people at the moment, and we've had them navigate sort of obstacle courses, and so far we've had a lot of success with it. But looking forward to the rest of the summer, one of our team members has arranged to go test this on actual blind children, and we're going to see what successes or failures that has to later implement.
Can you set the distance from the object? So if you want to avoid anything that's 2 meters away, 3 meters away, or 5 meters away, how does that work?
Well, we could have. So far, we have the stop set at about a meter. But if we want to change that distance, we could just change the code to change the stop sound to come at a greater distance. So yeah, it'd be possible.
So what does the winner get? What are the prizes? What's up for grabs, Laura?
So the winner will receive £1,000 for their school to spend on design and technology equipment, and we feel that's really important with all the cuts that have been made to education recently. We really want to support D&T within the curriculum. They'll also then receive either an iPad or a GoPro camera for themselves. All finalists get a goodie bag as well, which has got some secret special prizes in. Second place can receive a drone or a mini rig speaker, and that's British made, so again supporting British manufacturing. And third prize is either a Kindle or a laser keyboard, so they've got a good selection there. They can choose what they like.
Halima, what have we got here?
So this is a high-end chick brooder, which is basically an enclosure for baby chicks after they're born up until about 2 months. And the idea was to create something that not only looks good but has all the features for chicks to be healthy and grow up. And I got inspiration from cat and dog houses, and can I show you? So when you look up high-end dog houses or cat houses, there's like beautiful things come up. But when you look up chick houses, you just get sort of plastic boxes or just makeshift things that people have made at home. And so it's kind of like a niche market product.
What's the comfort factor for them with this then? What do they get that's different to what they would normally be housed in?
Well, the chicks, they have the basics, so like the food, the water, the lampshade. But also because of this waste straw, the chicks are not, they can stay in there, and they're not, so when you have to clean the brooder, you don't need to like take them out and put them back in, so they're harassed less, you could say, because this is helpful because the mesh allows all the waste to fall through, and then the client can just pull out the waste straw. And not only for the chicks, but for the client or for the customer themselves, it looks good in their living room rather than having just a dodgy looking plastic box.
Is the plan these would come in various sizes, or is it just one size fits all?
So this is the first ever prototype I've made of this product, but hopefully I can develop it a bit more and make different products, different colours, maybe make it customizable. So that is the next plan.
So you can house small chicks and big chicks.
Yeah. So this, once chicks are about 2 months, they need to be transferred to something else. So maybe I can have that as my next project.
Good luck. Thank you.
Thank you. Thanks.
Hannah, what's this table design?
So this is Heard. The main feature of this is the fact that the tabletop can spin around, so it provides children with 2 different surfaces. One's mainly to eat off, so it provides them with a hygienic surface, and the other can be for drawing on or writing. It's trying to encourage them to learn and play and interact with each other.
Give us a demonstration.
So you can. So it's quite easy.
And with this, you assemble this yourself and leave it assembled, I assume?
Yeah, so it's all flat pack, comes in quite a small box. It only takes about 2 minutes to put together, really easy for nursery staff, which is what it's aimed at, but it's good for home use as well. The shape allows lots of them to tessellate together, which again can create a nice environment for the children to be in. But yeah, you can leave it up like that as long as you want.
This is obviously an important part of the MTA's calendar, but tell us a little bit about the MTA and your relationship with education.
Okay, so I oversee the education development activities for the MTA. We have our member services side where we support our members in terms of providing apprenticeship grants and training grants so that their employees can carry on learning throughout their career. We then have our outreach activities, and that's really about promoting careers within manufacturing technologies and engineering to schools, and to help focus on closing the skills gap and to raise awareness with teachers and parents that really there's a lot of perceptions, outdated perceptions about engineering, and we're really working hard to change that and say that this is such a modern, innovative area to work in. So apart from the TDI challenge, we also work closely with organisations like the Design and Technology Association, Women in Science and Engineering, Tomorrow's Engineers. We're trying to increase industry engagement with schools, so I'd really encourage companies out there to go into their local schools, to have open days so that schools can come and see technology working.
Guys, what is the hub cooler?
The hub cooler is a device that cools the hub of an alternator.
So what is the problem that you've tried to solve?
The problem that we tried to solve was in relationship with McAlty. We wanted to cool the hub in a reduced amount of time. The original time was 3 hours, and we wanted it in under an hour. The hub is the part that attaches the alternator to the engine.
Which is this piece here?
This piece here, yeah.
And what was the outcome? How did you do it, and how quick did you cool it in the end?
So the most optimum solution was to use two fans, one pushing cool air into the hub and one pulling the hot air off it. That cooled it in down to half an hour from about 3 hours without any cooling method at all.
And is there a lot of consumption in power though to do that?
So there is some consumption in power, but it can be used off this battery, which means that they can use it very portably.
So the problem for their production is the fact that they cannot go near these things for the 3 hours until they're cooled, correct?
Correct. They have a bottleneck in their production line, so by cooling it in a fast enough time, you can increase the amount that they produce a day.
We also have an education development zone at MAC exhibition, and we get, last year we had 3,500 students through our doors. We have the students toured by apprentices and graduates that are working in industry, so you've got some role models there for the students. They're finding from someone just a few years older than them what it's like to work in the industry and the different careers that are available for them. So, we do try to do a lot to close the skills gap, and particularly at the moment there's only 9% women that work in engineering, and again we're really trying to help encourage more girls into the industry, make them realise the wide range of careers that are available for them. So that's the work we're trying to do at the moment.
Drones are a popular topic at the moment. What have we got here, Sam?
This is it's a fixed-wing search and rescue drone that the RNLI can use to lob off the side of a lifeboat and go and look for a survivor without having to pay for the cost and the time that it takes to get a search and rescue helicopter out there to do a similar task.
So using that as an example, how does it identify somebody?
So this doesn't because of budget reasons, but it would have a thermal camera on the bottom sitting in a gimbaled mount that it can detect the outline of a warm survivor against the cold sea, and it transmits that video signal back live to a pair of video goggles. So it's like you're in VR, like you're sitting in the aircraft, and where you look, the camera looks, and at that point you can locate the survivor in the sea.
Is there nothing in use like this at present?
Not for the RNLI. The military have a similar system in that it can be launched off a boat, and there are similar rotary drones, but they don't have the 85 mile an hour like top speed that this does, so it can get to places quickly. They can't fly for an hour, and they can't fly in the high wind conditions that this can. So this is much more suited to kind of sea-based applications and long-term or semi-long-term search operations lasting 45 minutes or more.
And which part of this have you developed? The actual drone itself, the software, the hardware, which?
Pretty much all of it. The only thing I haven't done especially is the flight controller, which is an open source flight controller called the RG-Pilot, which is a board that I've bought along with the GPS unit. But the airframe, all of the design of it, the power system, which was a pre-bought motor, but it's all kind of cobbled together with a speed controller and everything, that's all been designed by me.
How long has it taken you?
Too long? I don't know. It's been going since kind of Christmas. It took probably 3 months to get this to the stage where it is, plus all the documenting and stuff that you have to do for the A2 folder. So.
What a fantastic morning here at Mazak. So many youngsters using their initiative and designing and innovating products. I've got to say, this really is a fantastic event on the annual MTA calendar. Well done to the MTA, but also well done to all the students that took part. We know there is a first, a second and a third prize, but from MTD's perspective, they're all winners.